Comparing data. In this video, you'll learn how to compare and contrast situations using measures of center and measures of variability. A typical value describes what is common, expected, or most frequent in a dataset. We can use the mean or median to find these typical values. The type of data we have will determine which measure we'll use. We'll use the mean when the data is symmetric and there are no outliers. And we'll use the median when the data does have outliers or if it's skewed. 20 students participated in a psychology experiment that measured their heart rates in two different situations. So the plots show us situation A and situation B. Both sets can use the mean to find a typical value. Why? Well, we know that we can use the mean to find the typical value when the data is symmetric and there are no outliers. When we look at both of these dot plots, we can see that they increase and then decrease the same way. So these are both symmetric. And they also don't have any outliers, so that's why we're able to use the mean to find the typical value in this case. Now let's decide which situation shows a greater typical heart rate. We'll start with situation A, so we'll add up all of our data points. This gives us a total of 1,750. Now we'll divide by the 20 heart rates that we have, which gives us a mean of 87.5. Now let's look at situation B. We'll represent each dot with a data point, and when we add all of the data points, we get a total of 1,700. Then we'll divide by the 20 heart rates that we have, which gives us a mean of 85. So now we can see that situation A has a higher mean at 87.5. Now let's look at measures of variability. When looking at a data set, we want to know how spread out the data is. It's important to know which measure would give us the most accurate spread. The range is best used when you want a quick idea of the spread, but the range is affected by outliers. The interquartile range is best used when the data has outliers. This is because it's not affected by outliers. The standard deviation is best used when the data is symmetric. The standard deviation may be affected by outliers, but not always. The dataset and some summary statistics are listed below. So we have this data set, and the mean is 16.62, the median is 17.2, the standard deviation is 3.11, and the IQR is 5.5. How does adding 5 to each of the values in the set affect the shape of the distribution? Adding 5 won't change the shape, but all values will just be shifted 5 units to the right. How does adding 5 to each of the values in the set affect the mean and the median? We'll find out by adding 5 to each data point and then finding the new mean and median. Currently, we have a mean of 16.62 and a median of 17.2. Adding 5 to each data point gives us this new set. If we add them all up, we'll get a total of 194.6. And if we divide this by the 9 points that we have, then we'll get a mean of 21.62. Now we'll find the median by crossing out the smallest and highest points until we reach the middle. So now we've reached the middle and see that 22.2 is our median. If we compare our new mean of 21.62 to our other mean of 16.62, we can see that it increased exactly 5 units. Our new median also increased by 5 units. So we can say that adding 5 to each value will increase both the mean and the median by 5 as well. How does adding 5 to each value in the set affect the standard deviation and the IQR? We can find out by adding 5 to each data point and finding the new standard deviation and IQR. Adding 5 gives us this set again. To find the standard deviation, we'll start with the mean, and we already know that the mean is 21.63 for this new set because we just looked at it in our last example. When we subtract the mean from each data point, we get the following set. Then we have to square each difference, and that produces the following set. When we find the mean of this new set, or the variance, we get a total of 9.67. So to find the standard deviation, we'll just take the square root of this variance, which gives us a standard deviation of 3.11. And we can see that this matches the original standard deviation, so adding 5 to each data point didn't change it. Now we'll look at the IQR, so we'll bring down our new data set. And then we can find Q1 by looking at the median of our lower half of data, which in this set gives us 18.5. And we'll find Q3 by looking at the median of the upper half of data, so we'll get 24. Subtracting Q3 and Q1 will give us an IQR of 5.5. And we can see that this matches our original IQR as well. So we can say that adding 5 to each of the values has no effect on the standard deviation or the IQR. To recap what we've learned, the mean and median are used to find typical values of the data set, and the range, standard deviation, and IQR are used to find the variability of a data set. Outliers can affect the mean, range, and standard deviation. Adding the same value to each number in a data set will increase the typical number by that same value, but it will not affect the variability.